All right, so we are going to talk today about how to program flow sensors. Welcome, Jonathan Caceres from Everthrive Landscape. The content for today is really about just programming the flow sensors in the WeatherTRAK basic setup, right? We've talked in the past episodes about OptiFlow, and that takes flow to a whole nother level, a conversation for a different day. What we want to talk about is just flow on Pro 3 and LC platforms, how to manage the data, how to get the flow sensors programmed, how to run the learn flow test, and how to use that information in an effective way. And then also how to monitor those stations after the learn flow test is done, what that information coming in at you looks like, and how to use it to manage your systems and effectively save time, manage efficiently. So Jonathan and I work together to create some great content around this. What I will be doing is running back and forth between demonstrations on standing at the controller and WeatherTRAK.net. So I think a lot of this happens for guys when they're standing out at the controller. And so I felt like that was an important part of the process to cover today. So we'll show you the button push on how to do a lot of this stuff and what it looks like online, where it lays it all out a little bit easier to see it all and digest it. So before we jump into that, again, flow is something that we can add to a WeatherTRAK. It is not a standard feature. It does require that we add a flow sensor to your system and connect it to the WeatherTRAK. That flow sensor sits on your main line and basically watches the water running through the pipe, lets you know how much water you're using at any time. And by measuring it, we can then manage it much better. And if you checked in on our episode 9, where I had my friend Danny Smith on the line, where we talked about choosing the right flow sensor for your project, a lot of our conversation really centered around selecting a flow sensor that reflected the usage of your system. Jonathan, how do you decide what flow sensor is right for your projects?
So, it's a kind of a common error of sizing a flow sensor for the size of the pipe that's there existing. So we definitely want to look at what's the range of flows that you see on your system. So, it can vary a lot if you have some drip stations on the same controller versus some large rotors. So definitely looking at what your lowest minimum flow rating is that you need versus the highest, and sizing that appropriately. So it's okay to put an 1.5-inch flow sensor on a 2-inch line or greater. It just depends on your flow range.
Yeah, absolutely. That's awesome. That's a great tip. All right, back to this. We'll go back in here. One thing I did want to cover is the spoken tolerance. The flow sensors that we see on the marketplace are all advertised to be within 3% of the actual measured flow. So when they're dialed in, they should match up within 3% of actual. That was one of Tom's questions. So if you're seeing a greater gap than that in measurement, there is probably something that you want to drill into. The actual sensor itself is plus or minus 3%. So when you're comparing it, that is what I look at. Now, the reason I brought this chart back up is because it does play a big role in how we program those flow sensors. So let's jump over and walk through the process of programming a flow sensor while you're out in the field, standing at a WeatherTRAK controller. And I apologize, but this is as big as my demonstration gets right here. So if you got squint your eyes to see it, I apologize for that. But the first step in adding flow is putting that flow sensor on the pipe. And that is an art and a science unto itself, right? You got to get the hardware in place first and foremost. We're going to pick up our story where you've already done that. And the last step in installing flow is turning the flow sensor on in the program, in the controller, and watching it measure flow and making sure that the measurement that you're getting is accurate. So I want to walk you through that first step. And if you're standing at the controller, that lives on the flow menu. You go to flow, push the flow button, and then forward brings you to the select flow options. And that's where it can get tricky, because that's where this is the big menu, right? And the first thing that comes up is points of connection. This is where we dial in all of the points of connection, or the components on your point of connection. So we'll advance to the next screen, and you can see here we're going to manage point of connection 1. And the little cursor is under POC, the first question on this screen. So since we want to manage POC 1, we'll go forward, and you'll see the cursor move to under the master valve. We can set the master valve in this scenario. A flow sensor often is accompanied by a master valve. It gives us the full scope of the reaction, right? The master valve allows us to shut that main line down if there's a problem. So you would select whether you have a normally closed NC master valve or a normally open NO master valve. We'll just leave it as normally closed, and then move to the next question. FS1, this is our flow sensor, right? And we want to just turn that on this screen. Once we turn that on, we are safe. We can advance past. We don't want to add a pump start in this conversation. We want to make sure that it's assigned to the right main line. And when we scroll all the way through, we get to flow screen 2.7, which is where we select what type of flow sensor we want. Now, with WeatherTRAK, we select the flow sensor by part number. We've gone through and put in all of our known compatible flow sensors. So you find the right size and the right type of flow sensor that you're installing. And WeatherTRAK has stored all of the advanced information that we use to make you look up to find, right? We've got all of the K values and offsets programmed in here. So all you have to do is find the type of flow sensor that you're using. We're going to say that you have an 1.5" WeatherTRAK Flow 3, and then it will tell you to configure this sensor into the program. You have to hit the star button. That is different because this is the only screen on WeatherTRAK that you actually have to hit a save button to have that configure. But we don't want that happening by accident. It can have catastrophic effects. So you configure your flow sensor, and that's really all there is to setting that up. Unless I missed something. Jonathan, did I miss anything?
No, I would just say that make sure you have the time to complete this process. Once you start it, you don't want to, start getting your flow sensor set up and return, in a couple days or something. So just set the times. Once you turn that on, just know you're live, you're reading flows, and you could start having alerts and shutdowns.
Great note. Great observation. Absolutely. That's the voice of experience right there if I've ever heard it. All right. So the flow sensor for me, the flow sensor installation isn't complete until we're accurately reading flow. And so once you have put your flow sensor in the ground and turned it on, we're okay to test and see if we're accurately reading flow. And with WeatherTRAK, that's super simple. All I need to do is turn on a station manually on the controller panel. I'll turn on station 1, and as soon as I add minutes, you'll notice that the diagnostics come up on the screen for you. So you'll watch station 1 run. If the flow sensor is reporting accurately, you'll see the MA, or the milliamp reading, which is the electrical pull for all of the electrical components. And you'll start to see this gallon per minute reading on the screen. And to see it moving is good, right? That means that we've got some signal coming. Jonathan, do you have a rule of thumb how you test to make sure that that's accurate?
Yeah, so when we first set up a flow sensor, when we turn on the station and get an idea, just see, first it's a good sign you see some numbers start to populate on the gallons per minute. But then we just want to do a quick check to make sure that it seems accurate, what we're reading on there. So I'll try and find a station that's close by and see, count the number of sprinklers on there, you know, on any manufacturer's brochure, you can look at flow rates, you know, based on the nozzle size. So you can kind of do some quick math and see, okay, I have 20 sprinklers. We should be running about 40 gallons a minute on this station based on, you know, the nozzle size, and then see if it's somewhat close. If it's way off, kind of take a step back, make sure we selected the right flow sensor, and just double check basic settings and make sure we didn't miss something there.
Right. I always say if you've calculated it at 20 gallons a minute and you're getting 22, you're probably right. If you've calculated it at 20 and you're getting 200, something's definitely. Keep working on that. Absolutely. Yep. That's awesome. Okay.
Give yourself some time for the line size to fill up too, and stabilize before you look at that.
Yeah, absolutely. Hugely important, and we will show you the setting on that. So the way that we test is we understand the station we're looking at, we have an approximate calculated value, and we compare that to what we're showing on the screen. You'll also see, to Jonathan's point, during pipe fill, that number gets larger. So you'll see it climb, and then kind of come back down and balance out. The balanced out number is what you're waiting for, because that's what really kind of shows what you're using at that point. So once we have programmed the flow sensor so it's reading flow accurately and we verified the accuracy, the next step is to run the learn flow test. Okay, and on the learn flow test, we are going to go and set up our, let's see, come on, where to go? Oh, I know, I hit the button. Sorry. There we go. So we go to our select flow options, and instead of looking at the points of connection, our points of connection are already set up. The next thing we want to look at is our main lines. And this is where the tolerances, we start to monitor for the global thresholds, right? So we look at the mainline break threshold. And for the learn flow test, I always advocate for turning this to alert only, because if it's set to alarm and action, then at any point, if the controller measures more than 50 gallons a minute, then it's going to shut that station down and move on. It's going to identify that as a problem. So I turn that to alert only, just for the duration of the test, so that we can run that test without interruption and not have the software identifying problems that really aren't problems. It's just inaccurate in the settings. So I turn mainline break to alert only. I also turn no flow to alert only, because I want to see if any stations are outside of that range. I don't want them to alert. So that's just in preparation for running the learn flow test. Once I've done that, I'm done with setting up my main lines for the learn flow test, and I go back to my select flow options, and I advance here to stations. This is where we're gonna start the learn flow test. We're gonna start focusing in on the station-based flow. So I go through the station flow menu, and this is all stuff we will revisit later on. We can exclude stations from flow monitoring if they are outside of the range of our flow sensor. But for the learn flow test, we advance up here to the first thing involved with the learn flow test says select stations to learn. And you can go in here, if I hit select, you can actually go through and identify one station at a time. This is more of a maintenance learning flow, right? If I change out nozzles or I add a head, I want to relearn the flow on one station. Anytime the hydraulic condition for a station changes, I want to relearn that flow, so I'm not monitoring an inaccurate flow for that station. So I can learn one at a time. If I'm running it for the first time, I can just hit star, and that will apply the learn flow to every station that you have active on the controller. Once I've got all of that in place, it'll tell me how many stations that I'm configured to learn. In this case, it knows I want to learn all 96 of these stations.
remember that little star trick to add all the stations, because it's kind of a hidden feature. And I don't know how many times I went through and I added each and every single station to learn flow before realizing you could do it all in one button.
That's a biggie, right?
And just one quick other comment I wanted to make too, before learning flow, one of the things that I like to do is, if you have a normally closed master valve, to do a master valve override. Once you see that you're already reading flows, do a master valve override to pressurize your main line and just see if you have any leaks at all in the system that register there. Even a good idea to check your water meter just to see if the leak detector might be spinning, if it's something that the flow sensor is not picking up too. But just see if you have any leaks on your main before learning flows.
And that's a real important thing. Like, as we learn flow, you have to keep in mind, we want to learn accurate flows. So just like testing your main line, you want to do your best to make sure that the system is running the way that you want it to run. Broken heads will learn a false flow value, right? And so you want to make sure that, I make it a rule of thumb to walk the site with the system as it's learning flow, and identify things that might throw off that flow test or the accuracy of the results for that station. Yeah. So broken heads or buried heads, or whatever it might be, are things you want to flag and then fix and then relearn the flow later on, right?
Yep.
Great tip. All right, let's go back. So once we have set up which stations we want to learn, the delay before learning is the duration that we're going to run each station so we can learn an accurate flow. We talked earlier about how, as stations transition from one to the next, there is an inrush current. The flow on the system goes up and then comes back down and balances out. And we want to account for that, right? We want to make sure that we give the system enough time to balance out before we learn the flow for that station. And that's what this delay before learning setting is all about. This is saying that we want to run each station for 3 minutes, and that will give it enough time to balance out. If you have slow valves or super long runs, or anything that would indicate that it takes more than 3 minutes to accurately learn flow, you can bump this up. I see 3 minutes as a pretty fair assessment. Most of the time that works for me. But if you have a unique situation, you can definitely go in and change it. Jonathan, do you have any other examples of when you change that?
Yeah, so if you do happen to get high flow alerts, and you go back and you check the station and you notice that everything seems okay, it could be that there's just more fill time needed that you're not seeing. So just if you have one of those ghost high alerts that you can't figure out what it is, that might be one of the things to look at.
Absolutely. All right, there we go. Now we are cooking with gas. We are so close. You get through the delay before learning, and then all you got to do is, boom, turn it on, and that will turn on station 1. It will run station 1 for 3 minutes. You can actually watch it here on the screen. You can watch the gallons per minute. Again, I like to walk the site and validate that everything is working the way it should. But as it's going to run station 1 for 3 minutes, at which point it's going to document how many gallons per minute station 1 uses into the program, and turn off station 1, turn on station 2, and repeat the process, in this case 96 times in a row, right, for every station on your site. So that is the learned flow process. Now I'm going to skip out of the button pushing demonstration, and we're going to look at the rest of this on WeatherTRAK.net. So again, anything that you can program at the controller, you can also program on WeatherTRAK.net, including all of this flow sensor information. So we go back here and we look at the flow settings. I've got this one dialed in, a 2-inch data industrial. We've learned flow on this controller at this point, okay? Now, once you've learned flow, the programming isn't done yet. We went and we turned the mainline break threshold and the no flow threshold off. Now we want to visit how we calculate the values that should be plugged in as your mainline break and your no flow alerts. Jonathan, do you have tips and tricks for that?
So on the no flow alerts, yeah, that's something that say you came onto a site that has an existing 2-inch flow sensor, and you have drip stations on there that read well below the threshold there. So you're either probably going to get a 0 flow reading, or even if you do pick up a reading of 1 or 2 gallons a minute, it's probably not very reliable. So those could be some stations that you would exclude from your no or
Keep
low
talking.
flow.
I'm just going to bring this back up, but what Jonathan's talking about lives right here. Keep going.
Yep. So any station that say station 2, for example, it's a drip station that runs at 2 gallons a minute, and you recognize that that's below the threshold of what your flow sensor accurately reads. You're going to want to exclude that station. Even if you do get a flow reading of 1 or 2 gallons a minute, you just select that number 2 right there. That'll exclude that station from those alerts, because it's just, even if you get that reading, it's very inconsistent because it's just out of the threshold of the
Right.
flow.
So one of the things that I advocate when we start to set up, when we've learned the flow, we use these flows of our system to set our mainline break threshold, our no flow threshold, and our leak threshold. And I think the best rule of thumb is to go back to your literature for your flow sensor and find out the low end tolerance of that flow sensor. In that one we were looking at, it was 5 gallons a minute, right? And so I use that 5 gallons a minute for my no flow alert threshold and my leak alert threshold. So no flow alert is constantly monitoring. If we try and turn something on and it doesn't turn on, it will create a no flow alert. Leak means that water is running during non-irrigation hours. So during non-irrigation, if the flow sensor starts spinning, you can be notified of that. So I think that low flow tolerance for your sensor is a great place to set both the no flow alert and the leak alert, and then look at the results of your flow test, and anything that comes in underneath that level, anything that comes in underneath that 5 gallons a minute should be selected to no flow exclusion and low flow exclusion. Because even if they're measuring, to Jonathan's point, they might not be measuring reliably. And in the course of irrigation, they might drop to 0, at which point the no flow alert gets created and scrubs the irrigation. But you don't want that to happen. All right.
Just going back to the mainline break threshold too, keep in mind, so, like all these stations that have learned flows here, they're at, what are we at? So there's 15, 35, 13. So any one of those would be under the mainline threshold. But keep in mind that if you want to run 2 stations at the same time, that you have to add up those flows and account for that on your mainline break threshold.
Yeah, absolutely. I call it the highest anticipated flow, right? We have to use our highest anticipated flow to calculate what our mainline break threshold should be. So if I'm running 1 station at a time, I can do that safely here. But because I'm set to 100 gallons per minute, I've got this guy running at 59 and this guy running at 60. If I want to be able to overlap programs, I've got those running on separate programs and I want to run those programs at the same time, WeatherTRAK can run as many as 8 programs at the same time to help manage those water window issues. And so if you're running multiple programs at the same time, this is a unexceedable threshold, right? This is something that if the controller measures your mainline break threshold, it's going to stop. And so you can't program it in a way to exceed that. So you want to make sure that you're calculating your highest anticipated flow and making sure that the mainline threshold, the mainline break alert threshold, is set, I say 10 to 20% above your highest anticipated flow.
Mm-hmm.
All right. Anything else, tips and tricks on dialing that in, Jonathan?
Just jumping into the stations here, the default for learning the flow, it's set for 20% here. So, depending on the range of the flow for the station. So again, looking at, your small versus your big stations. So say you have a drip station that's running at 2 gallons a minute, 20% 2 gallons a minute is not much.
Not very much.
So just pressure fluctuations on that could trigger a high flow alert. So like on those very low stations, if your flow sensor is able to read that low, you might want to jump up your threshold, at least a gallon, a full gallon or 2 gallons above, what that drip station normally runs.
Absolutely.
Same goes on the high end. 20% of a station that's running at 80 gallons a minute, is quite a bit. That's 16 gallons a minute. So maybe if you want to fine tune that a little bit more, you might want to knock that down a bit. So look at both your high and low ranges on that, and you can customize them all.
I like that a lot, for sure. Keeping an eye on that and making sure that the alert matches a normal, rational response, right? You don't want to respond to a nothing break, and you don't want to let one run undetected. So depending on the size, you want to really dial that in.
So it's a good starting point. It's a good starting point, using the defaults, and then take it from there to dial it in as best you can.
Absolutely. And the one thing that I get asked a lot about is like this. I've got an alert notification saying that during irrigation on this, I was supposed to measure 13. That's the high limit on this notification, right? So this station learned at 11. It's supposed to alert at 13, but it measured 15. It just barely bumped out of that range. How do you manage that? Like, in my eyes, that could be a break, or it could be just natural fluctuation in pressure between the time that we learn the flow and the time that we're actually running the irrigation, right?
Yeah. So a couple things to check. So one would be, turn on your station as the most obvious one. See if you have any breaks. If you see that you have no breaks and you're exceeding the threshold that it was learned at, I'd also recommend, picking up a slow leak on your main line that may not be picked up as a leak because it's under the threshold of the flow sensor. But when that station's running, that extra 2 gallons per minute could be enough to set it above the level. So check your main. If both of those seem intact, then you could just be looking at pressure fluctuations that are happening from the time that it was learned versus when it's running at night. And the differences in water pressure can change that a bit. So if everything checks out, then you can go ahead and go back in manually and change your station flow rate right there, and then that'll bump up your threshold to
right.
what.
So the system will automatically default to the learned flow value, but you can go in here and user define a flow value. So I can go in and look at that alert notification and say it was supposed to be 11 gallons a minute, but I know I've checked and the system is intact. And when it runs at 15 gallons a minute. So I come in here and user define that flow rate for that station at 15 gallons a minute. And then I'll get my 20% above and 20% below. It will put that right smack in the middle of the window that we expect that station to operate in. And it'll eliminate a lot of what guys see as false alerts, right? That 1 gallon per minute over. Because if it's right on the edge, it can easily, as soon as it tips up over the threshold, that alert is prompted.
And it's pretty surprising too what the flow sensors do pick up, and so it's easy to disregard 1 gallon a minute, but you definitely don't want to just blindly increase your threshold. It's just over 1 gallon, because it could just be one nozzle that blew off, and it's taking you over the limit now. So
yeah, but it's a very visible issue to your customer, right? That one that just barely over the limit is shooting 20 feet in the air. That's not something you want to just miss.
Yep.
Awesome. And that really kind of brings us full circle on installing, programming, and then managing against the information we're getting back. Any other adds before we wrap this conversation up, Jonathan?
Well, no, thank you. Thank you for having me on. And
we're not done. You still have a question to answer. I ask all my guests, what does WeatherTRAK save you?
So WeatherTRAK for us has definitely given us the ability to one, communicate with our customers. So I mean that saves us jobs, really. I mean, you know, communication is always something that customers, you know, will complain about when they're changing companies over, you know. So staying in communication, utilizing reports has been huge for us. You know, being proactive with irrigation has been huge. So one thing that saved us, I'd say, is jobs, not losing clients.
That's awesome. That's a great one.
Yeah.
Anything that contributes to the bottom line is a great answer for sure. So I think that's all we need to cover today. I really appreciate you making time for us, Jonathan. You were a great guest and had a lot of great insight. So keep up the good work. I'm happy to see you being successful. And go ahead, and if you got a message for everybody, take us out.
Well, yeah. Well, thank you, Ben. It's always great working with you and the whole HydroPoint team. And yeah, I mean, I'll definitely plug in HydroPoint. It's been a big part of our growing business, and yeah, we look forward to continuing working with you.
That's awesome. Thank you so much. And with that, I will bring you up on next week. Join us next week. Oh, I always got to plug the service. We are always here to support you. If you have any WeatherTRAK questions, call or email the support team at support@hydropoint.com. Check out our online resources. Not only do we have documents and articles on how to troubleshoot, but you can access all of the old webinar episodes. So go to hydropoint.com and look up the web programs right where you registered for this. If you follow that page down just a little bit farther, it gives you access to all of the recorded, all 20 episodes that we've got in the book so far. So if you want to look those up, definitely do that. And we're here to support your training needs as well. We've got online, on-demand, free training that is certified. So if you want to do that for your guys, also a whole library of stuff that I made for YouTube, just the little tips and tricks videos. And then next week, we will have our focus on a great feature of WeatherTRAK, the savings analysis report that helps our salesmen. So join us next week for that. Thanks, everyone.
Thank you.